The sources mentioned different approaches to risk-benefit analysis.
Yeah, that's the million-dollar question, isn't it? How do you make the call? One approach discussed is expected utility maximization.
Sounds technical.
It's kind of a mathematical approach. You try to estimate the probability of different outcomes, like a pandemic happens naturally versus a lab leak happens versus we develop a vaccine because of the research. You assign a value or utility to each outcome, often in terms of lives saved or lost. Then you calculate which path, doing the research or not doing it, gives the best expected outcome on average.
Did they give an example?
The ethical analysis paper did. They ran a hypothetical calculation for H5N1 GOF research, plugging in various estimated probabilities and consequences. Interestingly, in their specific example, the calculation suggested that pursuing the GOF research actually led to a slightly lower number of expected lives lost compared to not pursuing it.
Really? That seems counterintuitive.
It can be, yeah. But it highlights a key limitation. Even if the math points one way, especially when dealing with potentially catastrophic, low-probability events, our ethical intuition might tell us to avoid the catastrophe, even if the expected value looks okay. We might be extremely risk-averse when the stakes are that high.
Right. That pure calculation might not capture our aversion to, well, utter disaster.
Exactly. Which leads to other strategies, like Maximin.
Maximin, what's that?
Maximin is all about avoiding the worst-case scenario. You look at each option, do the research, don't do the research, identify the absolute worst possible outcome for each, and then you choose the option whose worst outcome is the least bad.
So in the H5N1 example,
the worst case if you do the research might be, say, a lab leak causing billions of deaths. The worst case if you don't do the research might be a natural pandemic causing millions of deaths. Maximin says, avoid the billions of deaths scenario, so don't do the research. It's very cautious.
Prioritizing avoiding the absolute worst outcome, even if it's unlikely.
Yes. But the downside is you might be too cautious and miss out on significant benefits.
Then there's Maximax. Sounds like the opposite.
It basically is. Maximax is the high-risk, high-reward approach. You look at the best possible outcome for each option and choose the one with the biggest potential upside, regardless of the risks. Much more optimistic, or maybe reckless, depending on your view.
Okay. And the last one mentioned was the precautionary principle. That feels relevant here.
Very relevant. The precautionary principle generally says, if an action might cause serious harm, even if the science isn't totally certain yet, you should take precautions.
So err on the side of caution.
Essentially. There are weaker versions, like the one in the Rio Declaration, which says lack of certainty shouldn't stop you from taking cost-effective measures to prevent serious harm. Then there are stronger versions that basically say, if it could be catastrophic, just don't do it.
But is the strong version always practical?
That's the criticism. One source mentioned Cass Sunstein asking the strongest version is almost incoherent, because not doing something can also have catastrophic risks. Like, not developing a vaccine could be catastrophic too.
True. So maybe moderate versions.
Yeah, like anti-catastrophe principles.
Yeah.
Focus on avoiding actions that seem reasonably likely to cause catastrophe.
Yeah.
But then you get into debates about defining reasonably likely and catastrophe.
Yeah.
The key takeaway seems to be about taking reasonable proportionate precautions based on the potential harm.
The analysis also briefly mentioned rights-based ethics and deontology. How do they fit in?
A rights-based view would ask if GOF research violates fundamental rights, like the right to safety. The tricky part is deciding how much risk imposition is ethically okay, since lots of things involve risk. Deontology looks at whether actions are inherently right or wrong, not just their consequences. The doctrine of double effect, DDE, comes from this. Applied to GOF, it might say the research is okay if the intention is good, scientific knowledge, and the potential harm, misuse leak, is a foreseen but unintended side effect, provided the good outweighs the bad.
But you're still responsible for foreseen harms.
Exactly. The source notes you still have a moral responsibility for harms you foresee and enable, which means you have a strong obligation to minimize those risks as much as possible.
Okay, all this ethical wrestling has definitely shaped policies. We talked about the 2014 pause. What's the current situation with regulations, especially in the U.S.? That 2025 executive order sounds important.
It is, yes. On May 5th, 2025, the White House issued an executive order aimed squarely at improving the safety and security of biological research. It really signals a push to strengthen oversight, particularly for research that could enhance pandemic potential, which definitely includes some GOF work.
So what are the main directives in this order? What's it telling agencies to do?
Several key things. First, It gives them 120 days to revise or replace the existing main policy document, the 2024 U.S. Government Policy for Oversight of Dual-Use Research of Concern and Pathogens with Enhanced Pandemic Potential.
Okay, update the rulebook. With what goals?
The goals are clear: stronger independent oversight, more accountability, think enforcement, audits, better transparency about what research is happening, and clear definitions of what research is covered, all while trying to make sure the U.S. stays a leader in biotech.
And enforcement is a big piece?
Seems to be. The order explicitly requires putting enforcement mechanisms into federal funding agreements. Teeth, basically. And it mandates reviewing this main policy at least every 4 years so it doesn't get outdated.
You mentioned earlier that some research isn't federally funded. Does the order address that?
It does, which is significant. It requires developing a strategy within 180 days to govern, limit, and track dangerous GOF and other high-consequence research that doesn't get federal money.
How would they do that?
The strategy needs to include ways to promote screening of synthesized dRNA in those non-federally funded settings, too, to prevent misuse. And if they find they don't have the legal authority to fully implement this strategy, they have to propose new laws to Congress to fill those gaps.
So trying to close potential loopholes, what about transparency?
That's another major focus. The revised policy for federally funded work must include a way for institutions to report dangerous GOF research and non-federally funded research, too. We're legally allowed to accord some kind of publicly available source.
Publicly available?
Yes, with caveats about not compromising national security or legitimate intellectual property. But the aim is more openness. And related to accountability, all life science grants or contracts must now include specific enforcement terms.
Like what?
Things like signed. Compliance is required to get paid. Researchers have to certify they aren't involved in non-compliant foreign research. A violation by one researcher could impact the whole institution, and funding can be revoked, with potential bans on future funding for violations.
They seem serious about compliance. Did the order define dangerous gain-of-function research?
It did provide a definition. It focuses on research with infectious agents or toxins that could enhance their pathogenicity or transmissibility in a way that could have significant societal consequences.
And it listed specific outcomes.
Yes, things like making the agent cause more harm, helping it evade immunity or vaccines, making it resistant to drugs, increasing its stability or how easily it spreads, changing which hosts it can infect, making hosts more susceptible, or, significantly, recreating eradicated or extinct agents like smallpox.
Recreating smallpox would definitely qualify as dangerous.
You would certainly think so, yes.
Okay, but finally, we can't really wrap this up without talking about the shadow of COVID-19. How has the pandemic itself changed the conversation around GOF research?
Oh, immensely. The COVID-19 pandemic, and especially the very public, often heated debates about its origins.
The whole lab leak versus zoonotic origin discussion.
Exactly. That whole discussion has dramatically increased public awareness and scrutiny of gain-of-function research. The possibility of a lab accident, even though the scientific consensus still leans towards a natural origin for COVID-19.
Right, important distinction.
That possibility has brought the potential risks of lab work, including GOF, into the spotlight for everyone, not just scientists and policymakers. This heightened public concern has undoubtedly fueled the recent calls for stronger oversight, more transparency, and tougher regulations that we see reflected in things like that executive order.
So it really forced the issue into the mainstream consciousness.
In a huge way, yes.
Okay. So as we bring this deep dive to a close then, it's just incredibly clear how complex gain-of-function research is. You have this fundamental tension, right, between its potential to really help us prepare for pandemics.
A potential huge upside for global health.
And these undeniable risks involved in tinkering with potentially dangerous pathogens. Serious risks.
Yes, and layered on top of that are these deep ethical considerations. Weighing benefits and harms, dealing with uncertainty, questions of justice, governance. The evolving policies are really society's attempt to grapple with all of that.
It's definitely a knotty intersection of science, ethics, and policy. And like you said earlier, no easy answers.
Not at all.
So here's a final thought for you, the listener, to mull over. When you weigh the potential benefits for global health, maybe preventing the next pandemic against those low probability but potentially catastrophic risks of accidents or misuse, what principles do you think should ultimately guide how we fund and oversee gain-of-function research in the future? How do we find that balance fostering the science we might need while ensuring public safety on a global scale? Something to think about.
Definitely something to think about.
Thanks for joining us for this deep dive.